I'm Pol Mac Aonghusa. I'm based in IBM Research in Dublin, and I'm lucky enough to lead the IBM research team that's contributing the computer science aspects to the Human Behavior Change Project. The idea is to produce the most effective research assistant that anybody could possibly listen for or hope for. Imagine that you have an artificial intelligence that just loves to read. It never gets bored, and it never forgets any facts that it reads. And when you ask it questions, it can gather together all of the data that it finds and then present hypotheses to you about, say, likely effectiveness of outcomes, or perhaps help you spot white areas that haven't already been addressed and could be interesting as research questions. So it's not that it will necessarily help you understand behavior change better, but it might help you organize your thoughts. It might help you research background. It might help you understand better if you're performing studies. It might help you formulate hypotheses better. And it might help you understand better the parameters in which likely behavior change interventions could or could not work. Well, I mentioned that this was probably the most boring reading machine in the world, and so obviously natural language processing is pretty key as a fundamental tool. We've been really trying to keep up with absolutely leading edge technologies in the NLP area, and we have a team of 3 specialists in IBM Research just contributing to the project. After that, we've been getting quite a lot of use out of knowledge representation techniques, where we try to organize the information that's been extracted into useful structures to help us pin together different facts, particularly when we're going to try and later on use reasoning techniques to formulate hypotheses or to answer questions. In terms of some of the individual techniques that we're then using from machine learning, deep learning, of course, we've been experimenting with that. We've been using standard sort of regression and classification machine learning techniques for most of the project. So it's really quite a broad field, and consequently, the contributions and publications from the team have represented that, covering quite a range of conferences in the computer science area. I think what we've really been learning is just how interesting and varied and diverse the range of expression is when people write research papers. And so, some of the most interesting discussions we've had across the team, and this is not just in the computer science area, but of course we've had to involve everybody, is really just trying to interpret the meanings of things. I think communication across a multidisciplinary team, especially for technologists, where we really have a lot of buzzwords and jargon, has been an interesting challenge. I think the behavior change ontology has really been a life-saving, a project-saving piece of structure that we use in order to help us organize the scope and range of activities that we're going after. How do we organize information that's been extracted from the papers? But the real challenge when you push together multidisciplinary teams is trying to translate. And so, we were certainly guilty at the beginning of the project of using overly technical terms constantly, of trying to kill the audience during team meetings with deep technical charts. And we by the end of the project, we've realized that visual cues, demos, explaining by showing is a lot more powerful than trying to explain through numbers. The main insight that I've had as a person in the computer science research area is the importance of what I would call interpretability rather than just explainability. And what I mean by that is that we as technologists tend to focus on explaining how we have configured the technology and imagining that sometimes that's sufficient for the audience. So we will tell you all of the settings that we have used when we've applied deep learning or some other form of machine learning. and in the belief that somehow that explains what has gone on in the black box. But in fact, what we really need to be thinking about, and this is particularly true when we talk about disciplines like behavior change, where humans are involved and where the consequences of recommendations can have impacts on people's lives, we really need to focus more on, is it possible to interpret the results? Well, I think we're at a very exciting point because we've spent a long time annotating documents, we've spent a long time extracting information, and it's taken us quite a while to get to the point where we are now able to synthesize knowledge and begin to think about producing insights for people. And so it's almost like watching the machine take a breath and become alive. I guess most of all, what excites me is getting to the next milestone in the project and beginning to see practical applications of the technologies. I'm really looking forward to seeing real people adopting the technologies and seeing how they play out as a useful contribution to the domain of behavior change.